For our introduction, titration were used to determine the unknown sample from the concentration of a known sample. Double indicator titration were used for the samples that has two endpoints, and indicators were used to determine and give sign to the sample. Bromocresol green titrate higher concentration of strong acid that turns color yellow to blue, while phenolphthalein is a weak acid and colorless in the solution. The goal of this experiment were to know the components and to determine the composition of unknown carbonate mixture.
Methodology. First is the collection and preparation of materials. The glasswares and the reagents used in this experiment were gathered from the chemistry laboratory, namely burette clump, dropper, graduated cylinder, spatula, watch glass, analytical balance, hot plate, iron stand, Erlenmeyer flask, beaker, volumetric flask, 0.1 HCl, phenolphthalein, bromocresol green indicator, and carbonate mixture. Second is the titration with phenolphthalein. 1 gram of unknown carbonate mixture was obtained and its mass was recorded. The sample was distilled in a 100 ml beaker of previously boiled water. A 25 ml aliquot of the sample solution was pipetted out in an Erlenmeyer flask. Then 3 drops of phenolphthalein indicator were added. 3 replicates were made. The burette was filled with a standardized 0.1 HCl solution. The initial volume of the titrant was recorded. The sample was titrated with HCl until the pink color disappeared. The final volume of the titrant was recorded. The total volume delivered was recorded as BPH. Third is the titration with bromocresol green. 3 drops of bromocresol green was added to the titrated solution. The initial volume of the titrant was recorded. Titrating with the standardized HCl was done until the teal endpoint was obtained. The final volume of the titrant was recorded. The total volume delivered was recorded as VBC. Lastly is the determining of the composition of the mixture and calculating the percentage of each component. The composition of the mixture was determined using this table. This table shows the double indicator titration of the carbonate mixture in the same flask. We can also calculate the millimoles of the substance present. Next is the formulas used to calculate the percentage of the substance. Percent NaOH is equal to millimoles NaOH times molar mass of NaOH divided by milligram sample times 100. Percent NaHCO3 is equal to millimoles of NaHCO3 times molar mass of NaHCO3 divided by milligram sample times 100. Percent Na2CO3 is equal to millimoles Na2CO3 times molar mass of Na2CO3 divided by milligram sample times 100.
And for the calculations, Table 1 shows the volume of HCl delivered using the two indicators with phenolphthalein indicator and bromocresol green indicator within the 3 replication. Volume of unknown carbonate mixture was 15 ml. Table 2 shows the qualitative analysis of carbonate using volumes at endpoints. So based on the experiment, we use the relationship for qualitative identification of the volume of HCl delivered using the phenolphthalein is less than the volume of HCl delivered using the bromocresol green indicator. So we use the formula on the table to compute the millimoles of the substance present in the mixture. Table 3 shows the calculated millimoles of sodium carbonate and sodium bicarbonate within the 3 replications. Next is the calculations of millimole of sodium bicarbonate and sodium carbonate in the 3 replications. We use the molarity of HCl given 0.1003 normality and we convert it to 0.1003 molarity. So, to compute the millimoles of sodium carbonate in replicate 1, we multiply the molarity of HCl times the volume of HCl delivered with phenolphthalein indicator. So, we calculate 0.8425 millimoles. And to compute the millimoles of sodium bicarbonate, molarity of HCl times the volume of HCl delivered with bromocresol green minus the volume of HCl delivered with phenolphthalein, we calculate 1.379 millimoles of sodium bicarbonate. Next is in replicate 2. Same goes with replicate 1. We multiply the molarity of HCl times the volume of HCl delivered with phenolphthalein and we calculate 0.8325 millimoles of sodium carbonate. And millimoles of sodium bicarbonate, we multiply molarity of HCl times the volume with HCl with bromocresol green minus the volume of HCl delivered with phenolphthalein indicator. So we calculate 1.379 millimoles. And in replicate 3, the millimoles of sodium carbonate equals to molarity of HCl times the volume delivered with phenolphthalein indicator, and we calculate the millimoles of sodium carbonate equals to 0.8375, and the millimoles of sodium bicarbonate equals to molarity of HCl times volume delivered with bromocresol green minus the volume delivered of HCl with phenolphthalein indicator. We calculate the millimoles of sodium bicarbonate equals to 1.379 millimoles. So table 4 shows the calculated percent composition of sodium carbonate and sodium bicarbonate. So calculations of percent composition of sodium bicarbonate and sodium carbonate in the 3 replications. So mass of carbonate mixture is equals to 1.0085 grams. We convert it to milligrams. 1008.5 milligrams. So the molar mass of sodium carbonate is equals to the 105.99 gram per mole, and the molar mass of sodium bicarbonate is equals to 84.01 gram per mole. So the calculations of percent composition of sodium bicarbonate and sodium carbonate in 3 replications. In replicate 1, to get the percent composition of sodium carbonate, the millimoles of sodium carbonate will multiply to molar mass of sodium carbonate all over the milligrams of the sample times the 100. So we get the percent of sodium carbonate is equals to 8.85%. So to compute the percent composition of sodium bicarbonate in replicate 1, millimoles of sodium bicarbonate multiply the molar mass of sodium bicarbonate all over the milligrams of the sample, which is 1008.5 milligrams times 100. So we get the percent composition of sodium bicarbonate equals to 11.49%. In replicate 2, same goes with replicate 1. The percent of composition of sodium carbonate is equals to the millimole of sodium carbonate times the molar mass of sodium carbonate all over the milligram sample times 100. So we get the percent composition of sodium carbonate equals to 8.75%. Percent sodium bicarbonate in replicate 2 millimole of sodium bicarbonate times the molar mass of sodium bicarbonate all over the milligram sample times 100. So we get the percent composition of sodium bicarbonate equals to 11.49%. In replicate 3, the same goes with replicate 1 and 2. So millimoles of sodium bicarbonate times the molar mass of sodium carbonate all over the milligram of sample times 100. So we get the percent composition of sodium carbonate equals to 8.80%. Next is the percent composition of sodium bicarbonate equals to the millimole of sodium bicarbonate times the molar mass of sodium bicarbonate all over the milligram of sample times 100. So we get the percent composition of sodium bicarbonate is equals to 11.49%.
Discussion. NaOH absorbs CO2 from the atmosphere and is converted into carbonate according to the equation shown in the slide. The titration of a mixture of NaOH and sodium carbonate with standardized HCl has two equivalence points as shown in the slide. The equivalence point of the first solution is due to the conversion of all the carbonate to bicarbonate and NaOH to NaOH as seen in the slide. The phenolphthalein indicator, which is usually colorless, changes its color from pink when the pH is 8.2 and purple at even higher pH. Bromocresol green or BCG is yellow at acidic pH level of 3.8 and blue-green or teal at pH of 5.4. Conclusion. The students was familiarized with the different steps for a typical double indicator titration procedure, gained knowledge on advantages of double indicator titration over the single indicator titration, and determined the composition of the carbonate mixture using the table of double indicator titration of the carbonate mixture in the same flask. The result of the gathered data showed that BCG is greater than a BPH, which means that the substances present in the unknown carbonate mixture are sodium bicarbonate and sodium carbonate. Polyprotic acid or base has more than one endpoint and therefore needed to be titrated more than once, dependent on the pH level of the solution. The distilled water was boiled using dissolving carbonate mixture to remove CO2 present in all water that can make the water more acidic. That's all for our presentation. Thank you.